Hydroponic nutrients are where many new growers freeze up. Perhaps you can understand the concept of pumps and lights, but then you see the shells of bottles and powders and wonder, what do I do with this? This is an intro overview, not a step-by-step mixing lesson. I'm going to give you a simple roadmap of the concepts that will help you build your nutrient mix confidently. A nutrient solution is water mixed with dissolved minerals. This is the same mineral nutrition plants absorb when sitting in a field, except it is created by you rather than the rain and soil. There are 3 practical ways to build that mineral mix. We'll introduce them from easiest to most challenging. The easiest. 1 part nutrients are all in 1 concentrates. You add them to water and follow the label. The upside is simplicity, fewer decisions, fewer ways to mess up. The downsides are cost and limited fine-tuning. A 1-part product is often a liquid, so shipping is expensive, and you typically have fewer options to tailor the formula to a specific crop. If this is your first grow, especially lettuce or herbs, 1-part nutrients are a very reasonable starting point. 2-part and 3-part nutrients are the sweet spot for most growers. They are typically packaged as Part A and Part B, and sometimes the manufacturer will give them fun names like Flora Bloom or Flora Grow. Why split them up? It's compatibility. Some minerals are fine when they're dilute in your reservoir, but react when concentrated together. Calcium is a classic example. If calcium meets high concentrations of phosphate or sulfate, it can form precipitates, solids that drop out of the solution. Once that happens, plants can't use those nutrients, and equipment can clog. Separating ingredients into Part A and Part B stock solutions helps prevent that. Multi-part systems also give you the flexibility. Brands like General Hydroponics provide crop and stage guidance without requiring you to do the chemistry from scratch. Custom mixing means buying basic mineral salts, calcium nitrate, magnesium sulfate, potassium nitrate, and so on, and then building your own recipes. It can be the lowest cost approach at scale, and it gives you full control, but it has the steepest learning curve. You need greenhouse-grade, fully soluble materials, and you need reliable calculations. Here's the core idea. Fertilizers publish percentages here on the label. Calcium nitrate is commonly about 15.5% nitrogen and 19% calcium. If you add 100 grams of calcium nitrate, you've added about 15.5 grams of nitrogen and 19 grams of calcium. If you keep in mind that 1 part per million is equal to 1 milligram per liter, you'll be able to calculate the appropriate amount of fertilizer to add to reach your target parts per million. You repeat that logic across the other salts until you match your desired nutrient formula. An easy way to do these calculations is with a spreadsheet or software. There isn't one perfect formula. Experts have been designing and tweaking formulas for the last 100 years. A common solution used in scientific trials today was first formulated by Hoagland and Snyder in 1933. A formula includes the desired parts per million of each of the 12 nutrients we discussed earlier. But there is no single answer. To give you an example, let's look at just the nitrogen content in some various formulas. Hoagland's formula called for 210 parts per million nitrogen. Later, in 1966, Hewitt recommended 168 parts per million. Then Cooper comes along and suggests a range of 200 to 236 parts per million in 1979. Iowa State is currently happy with anything between 100 to 200 parts per million. And here at Skybound Acres, we copy Cornell and North Carolina State's use of a modified Sonneveld recipe, which calls for 150 parts per million nitrogen. The point is not to memorize numbers. It's to realize the acceptable range is broad, and there is room to maneuver. However, the range is not limitless. Plants can show deficiencies when nutrient concentration is too low, toxicities when it's too high, and imbalances when one nutrient blocks another. High potassium, for instance, can reduce calcium and magnesium uptake. That's why more nutrients is not automatically better, and why proven premixes reduces risk. Bottom line, if you buy a premix and follow the instructions, your initial working solution will have what it needs. No discussion of nutrient solutions is complete without mentioning pH. pH is the gatekeeper. It doesn't change how much nutrient is in the tank, but it affects how available those nutrients are to roots. Most hydroponic systems aim for a nutrient solution pH between 5.5 and 6.2. Outside that range, you can see nutrient lockout even when your mix is correct. If you want the simple start, use a 1-part concentrate and follow the label. If you want the best balance of simplicity and flexibility, use a 2-part or 3-part nutrient line. If you're ready to scale or dive into chemistry, move toward dry salts and custom recipes. Just expect a little bit of a learning curve. We are excited you've tuned in to learn about hydroponic solutions. Stay with us and continue the journey with pH management. Subscribe, and we'll see you there.